Hello and welcome to lesson 8.3. This is about solving for a specified variable. Sometimes it is necessary to use algebraic rules to manipulate formulas in order to work with a variable embedded within the formula. Remember all the different ways we've learned to solve quadratics and apply those methods here. So on this first example, it says to solve each equation for the indicated variable. So in the first example, we've got a squared plus b squared equals c squared. And we're going to solve for a. So you can see, you may recognize this as being the Pythagorean theorem. So in this example, we want to get a alone. And so just make note here, we're looking to get a alone. So we remove, on the left side of the equation, we've got a squared plus b squared, so remove the part that doesn't have the variable in it. And so the variable being plus b squared, the opposite of adding b squared would be subtracting b squared, and we have to do that to both sides. So then we're left with a squared on the right is equal to c squared plus b squared. And we're almost there, but a squared is not a, so we want to get the inverse operation. And this is the way we do a lot of these algebraic manipulations that they called it above, are just doing the opposite. So in the past, I've told students you have something here that looks like a yin and a yang symbol, and the opposite of addition would be subtraction, and the opposite of multiplication would be division. The opposite of this squaring a number would be taking the square root of the number. And so since a is squared, we can undo that squaring by taking the square root. But whatever, just like the other operations, whatever we do to one side, we have to do the same thing to the other side. When you take the square root of a number, you have to introduce the plus or minus. And so this is a is equal to plus or minus the square root of c squared plus b squared, all under the radical. And now this equation is solved for a. That is your answer. All right, let's take a look at the next example. So in example 2, this one's a little bit interesting here because we have to solve for h, but we see that h is on the right hand side, and it appears twice. It appears in two different terms, and so we want to get those terms alone first. So what we'll do is we subtract 2LW, and we have to do that to both sides. And that cancels it on the right, leaving s minus 2LW on the left is equal to 2HL plus 2HW. And now, since we want to get h alone, we have two terms that both have h in it. What we're going to do is factor. So we take out the h, and we're left with parentheses, 2L when I take the h out of this term, I'm left with 2L plus, over here, when I take the h out, I'm left with 2W. And so now that I have h separated from those two terms, I can take those two terms and divide by all of that. So 2L plus 2W. Like we've done before, we have to do the same thing to both sides. So 2L plus 2W. And that cancels, and it leaves that alone. H is then equal to S minus 2LW all over 2L plus 2W. And that's our final answer. You could rewrite it with the H on the left. It doesn't matter if it's on the left or on the right. Okay, if we look on the next example, example 3, it says we've got A equals 6s squared. This is the area of a cube, in case you're interested. And so we're going to solve this for s. Alright, so we want to get rid of the 6. And since 6 and s squared, the operation that joins them, whenever you have a number right by a variable, it means multiply. So the opposite is divide. So we divide by 6. And that would cancel the 6's. Is equal to, let's see, area over 6 is equal to s squared. So the opposite, as I said before in the prior problem, the opposite of squaring is taking the square root. So we take the square root of the right side and of the left side. Remember to add the plus or minus whenever you take the square root of a variable. So this cancels, the square root cancels the square, leaving s alone on the right. And our answer, move that down a little bit, s then is equal to a over 6, the square root, plus or minus. And that's our answer, because we've got s alone now. All right, let's look at example 4. With example 4, this is again a little bit different because r is in the denominator now, so we need to get rid of that out of the denominator. So we're going to take it's g times m sub 1 times m sub 2 is being divided by r squared, and so we're going to multiply both on the right and on the left, sorry, this is by r squared. And that's going to give us f r squared. This f, by the way, is the force of gravity. And this big G is a gravitational constant. So f equals r squared is equal to g m sub 1 times m sub 2, and the r squareds cancel. So that's all that we have left on the right. Now we can divide by f to get the r squared alone, because we're trying to get r as our variable that we're looking for. So we're dividing both sides by f, and that cancels the f. So then we have r squared is equal to g m sub 1 times m sub 2, and this is all divided by f. So we want to get rid of that square, so the opposite of squaring would be square root. So take the square root of this side, and the square root of the other side, take plus or minus, and then we would say here that our final answer is r is equal to plus or minus the square root of g times m sub 1 times m sub 2 over f. And that'd be our final answer for number 4. Okay, now we've just got a couple more examples, then you can go practice, do some homework problems yourself and see how it goes for you. Let's look at example 5. So we've got y equals ax squared plus bx plus c, and then we're going to solve for b. Since b is right here, what we're going to do is we're going to remove the parts that don't have b in it, so from the right hand side where the b is at. So that's going to be our first step. So we're going to subtract ax squared. I'm going to erase this so you don't think we're dividing. Subtract c, and we have to do that same thing to both sides. So minus ax squared and minus c. Here this cancels here, and this cancels this, and we're left with, on the right, y minus ax squared minus c is equal to bx. And so then finally, we've got bx is b times x, so we're going to do the opposite of multiplying by b, which is dividing by b. You have to remember to divide everything by b, so we put that division bar under all three of those. That would cancel the b over here, and our final answer is x is equal to y minus ax squared minus c, all divided by b. All right, example 6. With example 6, we've got p is equal to 2x plus 2y plus 5xy, and we're going to solve for y. So this is very similar to one of the other problems that we've done. We've got y in this term, but we also have y in this term. And so we're going to keep those terms separate on the right hand side of the equal sign and remove first that 2x. So I'm going to subtract 2x, and that cancels that, and then we're left with on the the left hand side, p minus 2x is equal to 2y plus 5xy. So what would we do next to get these y's out? We have to, rhymes with tractor, right, factor. So we take p minus 2x equals y times, when I take y out of this term, I'm left with 2. And when I take y out of this term, I'm left with 5x. And so then I divide this by 2 plus 5x. And I have to do the same thing to the other side. 2 plus 5x. This cancels this, creating 1, and then our final answer then is y is equal to p minus 2x and 2 plus 5x. And that's it. That's how you do it. Now go take this chance to go practice some of the homework problems yourself. If you have any questions, you need help, let me know. You can call me or text me at this number, 801-413-3363, and that's a Google Voice number that I set up for this purpose. So if you have any questions, comments, concerns, doubts, comments, whatever the issue is, let me know. Please try to stay between the hours of 9 a.m. and 5 p.m. Outside of those hours, maybe a text is fine, and I'll get to it if I can. But if not, I'll get to you when I get back to work. Thank you. Have a good day.